Hello, this is Chapter 8, How to Work with Data Types. We are going to see some queries to convert data types, different data types into each other. And the basic types that we're going to work with is strings, numeric, datetime, and we will say something about large value data types. So string and numeric are kind of staple for all programming languages. And date time is important because it just happens to be so often in the tables that we are working with. We'll discuss the difference between standard character data and Unicode character data, as well as implicit and explicit conversion. So, as I was saying, string, numeric, and temporal, as well as some other. So, specific types for, say, string, var binary, varchar, char, and other. So, sorry, var binary is data type for binary data. Varchar, char, nchar, and nvarchar are for strings. The difference between varchar and char is fixed length, fixed size rather in bytes for strings, and varchar is for variable length strings. Two types to work with real numbers, decimal and float, and also various int types. We will discuss difference between decimal and float later. Oh yes, we also have nchar and nvarchar. Those are for Unicode characters. And we have timestamp, and I think timestamp will be changed and updated to raw version, and maybe it already was, but I did not check that out. So first of all, integer data types. You can use big int, which is 8 bytes, or you can use tiny int, which is 1 byte. You probably know that byte is 8-bit, so for tiny int being 1 byte, there is 128 options covering numbers from -64 to 63. And consequently for big int, 8 bytes, that is 2 to the power 16. No, sorry, I think that is 2 to the power 64, and that is like 15-digit numbers. All right, now to the decimal. So this is so-called exact numbers and exact real numbers. So decimal comes with two parameters, p, which is precision, and optional scale. P, precision, is how many digits after the decimal points, and depending on p and s values, the byte sizes are assigned. Money is exactly what you expect it to be, and so the 2 decimal points. Now, float and real are good for storing approximate values, approximate real numbers, and they are stored basically in scientific notation. For example, a number 0.02 would be stored as 2 times 10 to the power minus 2. And so the exact ones are the ones where you specify precision and scale, and floating point number is working with significant digits. Significant digits is basically when you convert the number to the scientific notation. If there was a bunch of leading zeros after the decimal point, or there are some trailing zeros, like in a number 2,100,000, those will be replaced with the corresponding powers of 10. As you know, when you're working with float numbers, if you do take the same numbers and, uh, for example, multiply them and or take sum or difference in different order, you may get different results up to some small error, which is accumulated just the way the numbers are stored in binary format. In any case, that is not an issue for us, and if you want to remind yourself about floating number operation errors, you can. It's about the same for every language. All right, so char and varchar, as I was saying, char is statically, the memories for char is allocated statically, and it's n bytes, 1 byte per symbol. For varchar is when you have strings of various length, and it's allocated dynamically. Whenever you are dealing with fixed length strings, char is better because it's faster. And one example of that, in the AP dataset, we had vendor state, which was 2 letters, and uh, in that case we used char. For other columns such as names, we used varchar. Now, Unicode characters, you can remember maybe that Unicode character, each of them takes 2 bytes because of a huge diversity of such characters. I think it's something like 64,000. So nchar for n symbols takes 2n bytes, and nvarchar for n symbols, I'm not exactly sure it's going to be 2n bytes. I mean, it will be allocated depending on the length of each string, but it may be not exactly the length of that string. Okay, I did talk about that. And finally, datetime format. The old ones are still in use, datetime and small datetime. And here are some new ones where n is not the length, it's specified number of bytes. And I actually have an example ready here. So let me look at the example. Don't worry about the code. This is just a column from payment date column from AP invoice copy table, and some conversions to datetime too. They are more precise. So payment date is small date, and this is datetime 2 with 4 bytes and datetime 2 with 5 bytes. By the way, if you want to check out the formats, the data types for any of these columns, you can open invoice copy, like I'm doing right now, choose columns, and in parentheses, the data type is the first, so integer, then varchar 50, small date time, and money. I think those are all the formats, all the data types for this table. Let's go back. As you know, there are various formats for date and time. Say year, 4 digits, then month and date, or with slashes. And you can spend some time learning this table with all the milliseconds. Here is seconds and milliseconds, or seconds and nanoseconds. So this is something that usually nobody remembers unless you work with it every day, and you just look it up as you need. Okay, so datetime literals. You need for datetime literals, you enclose datetime value in single quotes. If you don't specify time in datetime value, it will default to 12 a.m. or just zeros for the 24-hour date format. If you don't specify date, it defaults to January 1, 1900, and if you shorten your years to 2 digits, that's how they are going to be interpreted in a reasonable way. And that's about it with dates. Okay, we need to talk about large value data types. So if you want to store large text, varchar max, you can use varchar max, and the max means about 2 GB. I think exactly 2 GB of data. And varchar max, I think the bound is the same, but you're allowed to use more characters. Oh, by the way, for when we were talking about varchar and varchar, I should say that Unicode characters are useful if you have data in foreign languages, for example, or you want to be using some special symbols like pi in mathematics for some reason. And all of those are Unicode characters, and that would be an appropriate format. Well, maybe we don't really care at this point how data types were before 2005, but now these three are available. And I should say a little bit about var binary. Um, Sometimes you want to store, for example, images in your table. So var binary would be an appropriate format for that. And I think, again, the uh, upper limit is 2 GB. Okay, order of precedence, and if you take a glance on this at this table, you might able to guess where this is going. The order of precedence from highest to lowest, so maybe pause the video and guess what am I going to talk about next. Okay, so when you are doing some operations with these data types, such as multiplying two columns or multiplying a column by some number, or when working with strings concatenating two columns, there may be some implicit conversion going on. For example, and you remember that from any other language that you have been working with, float times integer, the result of that would be a float in Python, for example, because integer will have to be implicitly converted to float, and the result would be a more general data type. Similarly, if you have n varchar, which is variable string, and you are concatenating it with varchar, which is a variable string, but n varchar is Unicode, a more general type, the varchar will be converted to n varchar, and the result of concatenation will be n varchar. So that's the meaning of this table. All right, so for example, if you multiply invoice total by a constant for whatever reason, the invoice total was type money, but the result will be converted, it will be implicitly converted to decimal, and then the result will be in decimal. Very similar in the other examples. Payment date, if you choose to, for example, change payment date to this date, depending on condition, like we did it previously, this date literal is converted to small date time value because that was the format of payment date, as I showed you earlier. So there is implicit conversion. Sometimes there is no implicit conversion. You have to control explicitly the format, the type of the data that you will be using. For that, you can use, oh yes, so sometimes if you want to take a char such as the date and convert it to to date, you will have to, it converts implicitly, but the other way, some of the other ways, for example, date time to decimal or to uh, char, you will have to do that and you will have to specify. So char to money would have to be done explicitly, or money to character to characters would have to be done explicitly. So we have a cost function which can take an expression, usually it's a column, and convert it to a certain data type, if that is possible. So we're selecting invoice date, invoice total, then cast invoice date as varchar, and then cast it as int, and cast it as varchar, and we can compare the results. So this is a date, and this is the default conversion from date time to varchar. And this can be changed, and I will talk about it later, that this string can be modified. Notice that invoice total was converted to integer and it was actually rounded, not just the cents in the total were not just chopped off, they were rounded to the nearest integer for invoice total as int. And in case you want it as varchar, which is a string, it looks exactly the same, but now these numbers are actually in string form. All right, this is just an example. If we just do 50 divided by 100 in SQL, we get a result 0 because this defaults to integer division. So dividing 50 by 100 in integers is 0 plus 50, 50 being the remainder. So to get the answer that you probably want to get, 0.5, you divide 50 by conversion from integer to, say, decimal. And here is your result. Or you could do a float instead of a decimal. But since one of them was converted, the other one will be implicitly converted, and the result will be in this broader data type. All right, convert function is similar, but also it allows for style. Styles are encoded. I don't think there is any intuitive way to remember those codes, so it's just something that you look up, I guess. So convert varchar invoice date as varchar date. We are converting varchar to string format, and we are converting the invoice date column. And the result is right here. So this is now a string, and this is the default format for it. We can also convert using this style 1, and that's how it looks like. And we can also, that varchar date is right here, so this is how it converts by default. This is how it converts with style 1, and this is how it converts with style 107. Similarly, for the numbers, you can see that default and style 0, that would be just exactly the same appearance with but as a string. And in the last column, it's the same appearance but with commas for thousands, so that readability improves. If we're talking in numbers in thousands or millions, there will be corresponding commas. All right, so some codes 0, 100 default for datetime to character data. So that's some of the examples we have seen, like 107, I think we have seen in the previous one. So this is something just to look up when you need to. All right, style code for converting real data to character data. So 0 was the default, 6 digits maximum. 1 is what we have seen in the previous example, plus column of the previous example. 8 digits. Oh no, that last one was converting from money. That's why they were commas. So we did not make it to the last example. Okay. Converting money to character. So when we had style 1, 2 digits to the right of the decimal point, commas to the left. So every third digit would have a comma before it. And that's what we have seen on that example right here. So this comma is because the style was selected as 1, we were converting from money to varchar. All right, and the difference with try convert function is that it doesn't throw an error when you attempt to convert some value in a column and the conversion was not possible. So in this case, just to make a very specific example, in the last column, try convert date, we're converting the to the date format, and we're converting the value February 29, 2015. So this is just a constant value that does not exist, and hence the invalid date column is null. So it returns null when it cannot really convert. And the rest of the table should be exactly the same as the previous example. All right, so there are some other conversion functions: converting to string from float, converting to char from character to integer. How this works: ASCII encoding. So this char function of integer, I think the valid integers are from 0 to 255. It returns the corresponding characters to ASCII characters. And this one does the opposite. If you enter a character for a string, it will return its numeric code. By the way, over here you can insert an entire word and it would only return the numeric code for the very first leftmost letter. Same for nchar, only Unicode, and this is converting first letter in the string to its Unicode code. So here are some examples that do exactly that. So this one over here is keeping one decimal and it's rounding. And character of 79, that is ANSI character O. In other words, ASCII character for O is 79, so this is the opposite. And nchar, this is a Unicode character corresponding to the 332, and this example just to show you that it only takes the first letter of your string, and you have to put n in front of it to signify that this is you are looking for Unicode character. So the Unicode code for O is 332. All right, and ASCII codes for some control characters, tab 9, line feed 10, and carriage return 13. So here, select vendor name plus character 13, character 10, vendor address 1, and so on. That is creating an entry on multiple lines. So character 10 basically does the new line. I think you will see exactly the same output even without character 13, carriage return. Or I did not check that, but I think that's my feeling about it. So when you concatenate various names, you can various columns, you can use character 13 to character 10 to shift to the new line. And that's about it for chapter 8.